All right, everybody. This is kind of a continuation of our Monday lecture where we are going to take the muscles that I taught you guys about the neck, the main ones, right? Right sternocleidomastoid, left sternocleidomastoid, right erector, left erector, and the muscles that I taught you about the trunk on the lecture before. And we are going to play a super fast and exciting game called Identify That External Oblique. So one of the things I could do on the test is say, hey, identify all the muscles or which one's working, which one's not working. But an easy way to kind of shortcut that is identify which oblique. Obviously not in the sagittal plane, but if it's a frontal or a transverse question, identifying that one oblique, whether it's the right or left external oblique, tells me you know which group. Because once you got one muscle, right, you can get the others. So we're going to play this super fun, fast, and exciting game called Identify That External Oblique. It's either the left or the right. Remember, a lot of this is 310. 310 helps you figure out who's working because you understand why they need to work. Now I'm trying to get you to identify the muscles in those groups that you figured out. Okay? I'm helping you identify what you already learned how to identify. So after I ask the question or I set up the question, you can pause the video, get an educated guess, infer which oblique, and then press play, and we'll see if you're right. Okay, so this exercise right here, let's infer that the ball is very heavy so you can really get a sense of what the external force is trying to do to his trunk. This is going to be a transverse plane question. I'm going to say right external oblique. And I'm going to say that because the external force is trying to twist his trunk to the right. If he's holding it in this position for the picture, he needs muscles that are pulling his trunk to the left in the transverse plane. Those are the left transverse trunk rotators. 310 helped me to identify what group is needed. 415 is going to help me identify who's in that group. So who are the left transverse trunk rotators? The right external oblique is one of those. So I finished my question. Right external. The left external would what we would call an antagonist. Now you may say, well, wouldn't it be working as a trunk flexor in the sagittal plane? And you'd be 100% correct. But this was a transverse plane question. And although the right and left external oblique would be working in the sagittal plane, the right external oblique would be working more than the left. The right external oblique would be working more than the left external oblique because it would not only be working in the sagittal, but it would also be working in the transverse. Next question. Okay, identify which external oblique, right or left. Press pause. Come back. It is the left external oblique. Left external oblique working concentrically to bring you up, eccentrically to let you down, isometrically to hold you in that position. External forces are trying to bend your trunk to the right. If he relaxed everything, his pelvis would fall and his trunk would bend to the right. You need muscles that pull to the left. You need left lateral trunk benders. The left external oblique is one of those. What about, what if I said which sternocleidomastoid would be holding his head in that position? Press pause. All right, welcome back. Right sternocleidomastoid, preventing his left ear from going to his left shoulder or left lateral cervical bending. So he needs right lateral cervical benders. The right sternocleidomastoid is such a muscle. All right, this question obviously has nothing to do with obliques, but it's flexors or extensors. Does he need cervical flexors or cervical extensors? Press pause. Welcome back. He needs cervical extensors because that weight is trying to flex his cervical vertebra. Now, if you would observe extension, like if he brought the weight up, that would be the cervical extensors through concentric work. If you observe flexion, in this same situation, it would still be the cervical extensors, and it would be through eccentric work. So notice, contractions can change, motion can change, muscles in regard to their directional pull does not. So how do you explain that the same muscles are working through different motion, through different contractions? But what is the commonality in all those different scenarios? Isometric, concentric, eccentric is the direction of pull. Those muscles are pulling in the direction of cervical extension throughout. Let me make it bigger. Okay, remember, I'll ask a question. You can pause and then come back. She starts here. She flexes her knees, which has nothing to do with pelvic girdle rotation when your hands are off the ground, like I taught you in 310. She undergoes left lateral pelvic girdle rotation. Left lateral. So from 310, you got to remember what the trunk does when you're hanging from a bar and you have left lateral pelvic girdle rotation. So what muscles would it be, right external or left external? Right or left external would be working to create the left lateral pelvic girdle rotation. Press pause. Welcome back. Right external. She's making left lateral pelvic girdle rotation because she's making right lateral trunk bending. She's making her trunk bend to the right. So therefore, the right external oblique is going to be one of those muscles. All right, right external or left external? I might get tongue-tied, guys, just giving you a heads up, because usually when I talk about a right external, it's with a left internal, like I taught you, right? So I might stumble because I'm so used to saying right external, left internal, left external, right internal, and I'm giving you two different options, a right external and a left external as choices. So that's why I might slip up a couple times. So this exercise, right external or left external? Press pause. Welcome back. Right external. So again, in the transverse plane, the right external oblique is working twice as much as the left external. The left external is only working sagittal. The right external has to work sagittal and transverse. All right, let's work in a stretch question here, okay, before we get into agonistic influencers. Let's do a stretch question. If the person is holding the position on the right, okay, the one over there where she's bending, and she's just holding that. She's trying to relax her muscles. She's reached the end of her range of motion, so bone is kind of soft endpoints, firm endpoints, and her muscles being stretched are kind of ending her motion. Who is she stretching? Is she stretching right external or left external? She is stretching right external. Now, if she brings herself back to her anatomical position of her trunk, so she goes from this picture to that picture, right external or left external would be an agonist. Right external. And if she goes from the picture there to the picture over here, it would also be right external. Right external concentrically, right external eccentrically, right external isometrically. So what does a right external have in common? It's a right lateral trunk bender, which you're going to need those muscles that pull in that direction to make you move and then to let you go back or to keep you there. All right external or left external? Press pause. Welcome back. Right external. right external. Making him bend this way through concentric, letting him bend back through eccentric, or working isometrically anywhere in there. Okay. Okay, how about this question? He's doing, like, now remember, global references, local references. So knees come up. I'm not saying there's not some hip flexion there, but if he is going to get his butt off of the pad, he's going to have some posterior pelvic girdle rotation. See what I'm saying? And with that has to come trunk muscles to influence the pelvic girdle rotation. So my question to you is rectus abdominis or erector spinae? What you think in terms of influencing the motion, working, doing a job? Rectus abdominis or erector spinae? Welcome back. Rectus abdominis, creating the trunk flexion through concentric work. That external force is trying to extend his trunk, so he needs those flexors. All right, I'm not gonna, this is just more of a lesson. One of the reasons this isn't necessarily a good exercise is because you're balancing the teeter-totter. In other words, if you have two dumbbells in your hand, the weight of the left is going to counterbalance the weight on the right, and then it doesn't really take a lot of force to tip the teeter-totter. That's like having a perfectly balanced teeter-totter, and it only takes a little bit of push to make it go this way, and it's a counterbalance. So you got to drop one dumbbell to make one dumbbell try to move you in the frontal plane, and therefore your muscles are playing tug of war, not the other weight. So, all right, moving on. All right, how about a stretch question? Which oblique external on the right or the left is being stretched? Right external or left external is being stretched? Press pause. Welcome back. All right, well, from the perspective of his trunk, he is twisted to his right. He has right transversely trunk rotated. Okay, so all the muscles that pull in the direction of right transverse trunk rotation are going to be shorter. And all the muscles that pull in the direction of left transverse trunk rotation are going to be longer. So which of the obliques externus is a left transverse? It is the right. His right external oblique is being stretched. I might, on the test, throw out internal obliques. Well, if his right external is being stretched, his left internal is also being stretched. Okay, let's do some more stretch questions. Okay. This position, is she stretching flexors or extensors? Press pause. Welcome back. She's stretching flexors. Who are the flexors? Right and left sternocleidomastoid. This position, stretching flexors or extensors. Press pause. Welcome back. Cervical extensors. They are her right and left erector spinae. She is looking to her left. What is being stretched? If she's looking to her left, the muscles that pull her back to the right are being stretched. Right transverse cervical rotators. Who are the right transverse cervical rotators? The left sternocleidomastoid and the right erector spinae. The exact opposite here. She's looking to her right. Who's being stretched? The muscles that pull her back to the left. Who are the left transverse cervical rotators? The right sternocleidomastoid, left erector spinae. See how this works? What's she stretching here? Well, she's left ear, left shoulder. She has left lateral cervical bending. Therefore, she's stretching the right lateral cervical pullers, right lateral cervical benders. Here, she's bent to her right, so she's stretching the muscles on her left in the frontal plane. Okay? What about this dude and that lady? Left ear, left shoulder, left lateral cervical bending, therefore lengthening the muscles that pull right laterally. So he's stretching the right lateral cervical benders. All right, the TheraBand is trying to twist her trunk to her left in the transverse plane. So the external force is trying to twist her trunk to the left. The external force is trying to cause left transverse trunk rotation. Therefore, she's going to need her right transverse trunk rotators to do the job of creating right transverse trunk rotation or allowing left. But I identified the group. Thanks, 310. Now, who's in that group? If I know she needs right transverse trunk rotators, I think of my circle. Who pulls in that direction? Left external, right internal, right erector spinae. All right, I'm going to try to keep this one simple. Let's go with the bottom picture, okay? And yes, she's using a lot of different muscles to stabilize, but I'm specifically talking about trunk rotators, transverse plane. Would she need her right external or her left external? Right or left external, holding this position. Because the agonists are going to flip-flop if she goes from one end to the other end. So I'm just talking about this one position, okay? Now, press pause. Welcome back. So her trunk is twisted to her right. She has left transverse pelvic, but that means right transverse trunk. The external force is also trying to twist her trunk to the right. So she needs left transverse trunk rotators. That's where you come with your circles. Who are the left transverse trunk rotators? Right external, left internal, left erector spinae. So she needs her right external oblique to hold that position. Okay, let's play what's being stretched. On the test, if I say he starts with his knees in the middle and he rotates his pelvis in the transverse plane and his knees go to the right, what oblique am I stretching? Am I stretching right external or left external? So if his knees go to the right, he is undergoing left transverse trunk rotation because he has right transverse pelvic girdle rotation. If I'm twisting my trunk to my left, I am shortening left transverse trunk rotators and lengthening right transverse trunk rotators. My left external oblique is a right transverse trunk rotator. So I'm stretching my left external when my knees go to the right, and then my right external when my knees go to the left. Okay, from this starting position, he twists his trunk in the transverse plane to bring the ball back to his midline. Will I need the right external oblique or my left external oblique to do this job? Right external or left external? Press pause, come back, right external. Because I need my left transverse trunk rotators to do it, my right external is one of those. Which external oblique is being stretched here? Press pause, come back. Right external oblique is being stretched here. How can I prove it? Because he's bending to the left, so he's going to be stretching muscles that pull to the left. Remember, this is frontal plane. And so the right lateral are going to be lengthened because of left lateral trunk bending. And the right external oblique is one of these right laterals. All right, for this one, let's say he started in anatomical position in terms of his pelvis to trunk. Sure, his hips are flexed, sure, his knees are flexed, but regardless, if I say his anatomical position from his trunk, then you know that his pelvis is facing forward. He goes from there to this new position. there's no external force that's trying to make his pelvis spin to the left in the transverse plane. So he has to use concentric work to make his pelvis spin to the left. Therefore, he's using concentric work to make his trunk spin to the right. So what makes your trunk spin to the right through concentric work? Right transverse trunk rotators. Who are his right transverse trunk rotators? That's when you use your circle. Left external oblique, right internal oblique. So which external? His left external. All right, so this machine, his upper extremity is fixed, and his pelvis is going to rotate. And because his pelvis rotates, his trunk rotates. Now, we need to look for clues. Where's the start position and where's the finish? It would easily be tempting to say this is the start because his pelvis is in anatomical position. But illusions exist. Look at the weight stack away from each other. He's not going to start with magical floating weight stacks. He's going to start when the weight stacks are all stacked together. So that's his starting point, and he's going to make those weight stacks split apart. Concentric work, eccentric work. Well, now we got to figure out the trunk motion. So if he starts with his pelvis spun to the right, that's because his trunk is spun to the left. He starts off left transverse trunk rotated, and he goes to anatomical position. So how do you go from your trunk spun to your left to your pelvis back in anatomical? You have to have right transverse trunk rotation, left transverse pelvic because of right transverse trunk. And he made that right transverse trunk rotation occur through concentric work. So it should be inferred that I need right transverse trunk rotators to make that happen. My left external oblique is a right transverse trunk rotator. So I need my left external oblique here. All right, here's another who's getting stretched, and we could also look at it as who's getting worked. So let's say I start at the top left and I go from here to there, and I don't let gravity do it, so I'm using muscles to work to control that motion. Press pause, identify, come back, identify external oblique, right or left external oblique. Press pause, come back. So when he starts to move his legs across because of the left transverse pelvic girdle rotation, gravity is trying to spin his pelvis to the left. Therefore, gravity is trying to spin his trunk to the right. If the external force is trying to spin your trunk to the right, you need left transverse pelvic girdle rotators to let you go down through eccentric and to make you come up through concentric in that quadrant, in legs to the left quadrant. Okay? So external force trying to spin the trunk to the right. I need left transverse trunk rotators to play tug of war against it. Which external oblique is a left transverse trunk rotator? My right external oblique. I'd be working my right external oblique as long as I stay in that quadrant. Now, if he tips over the other way, now I would turn on my left external because the exact mirror opposite would be happening in terms of motion. All right, so here is a much better example of how one dumbbell now can create an unbalance in the teeter-totter that your muscles have to work against, okay? So which external oblique would I be working in this exercise? Right external or left external? Welcome back. Right external oblique, because I would need my right lateral trunk benders. My right external oblique is one of them. Okay, we're going to go rapid fire. Rapid fire. Top left, what muscles? Welcome back. Cervical extensors, right and left erector spinae. Top right, which muscles? Welcome back. Cervical flexors, right and left sternocleidomastoids. Next question, Which muscles? I need my left lateral cervical benders. That's my left sternocleidomastoid, my left erector spinae. Last one. Bottom right. I need my right lateral cervical benders, right sternocleidomastoid, right erector spinae. All right, he's about to twist his trunk. Which external oblique in the trunk's transverse plane? Right or left external? Press pause. Welcome back. He is going to need his right external oblique. Right external. Here's one that I could see if you really understand. I can give you, hey, if we go from this picture to that picture, there's going to be eccentric work. That's true. And you're going to have right lateral trunk bending. That's also true. So again, I could try to mislead you, but I'm really trying to see if you know your stuff. So if I have eccentric work that's going to be responsible for right lateral trunk bending, which external oblique do I need? The left external, because it's still going to be working eccentrically to let you bend this way without hurting yourself or getting your center of mass over your base of support. Left external oblique. Okay. Let's not pay attention to hips or knees because we're not there yet. This is just trunk. So we're going to start at the bottom and then we're going to go up. In addition, I'm going to say I'm specifically asking you which external oblique, right external, left external, in her frontal plane. So let's infer she has some left lateral trunk bending when she goes from there to there. So which external oblique would I need? Left external. Left external through concentric work, making her bend to the left. Because if she relaxes everything, she's going to go back to her right. Okay, for this one, is this a start position or a finish? I guess start and finish could be the same position, I guess. Is this the start of her range of motion or the end of her concentric range of motion? This is the start. The plates are together. She just stepped in. She is going to concentrically, she's going to use concentric contraction, concentric work to make her pelvis spin to her right. This is true. And because she's making her pelvis spin to her right, her trunk is going to be made to spin to its left also through concentric work. So if I have left transverse trunk rotation through concentric work, I need my left transverse trunk rotators. You use your circle to identify which external oblique. Right external oblique. Okay, let's infer that this is a TheraBand. It's pulling in a direction of the TheraBand's inferent pull. 3A to 3B, cervical flexors through concentric work. 3B to 3A, cervical flexors through eccentric work. 3A, cervical flexors, isometric work. 3B, cervical flexors, isometric work. Who are all those cervical flexors? Right and left sternocleidomastoid. 4A to 4B, cervical extensors, eccentric work. B to A, cervical extensors, concentric work. 4A, cervical extensors, isometric work. 4B, cervical extensors, isometric work. Who are the cervical extensors for this class? The left and the right erector spinae. 5A to 5B, left lateral cervical benders, eccentric work. 5B to 5A, left lateral, make sure, right lateral, sorry guys, 5A to 5B. So I started, usually I went from B to A, so sorry about that. Let's start from the beginning, okay? 5A to 5B, the external force is trying to bend his neck to the left, okay? So it's trying to make him go there. So if he's going to make it go in the opposite direction, that's concentric work. So he's going to be using his right lateral cervical benders through concentric work from 5A to 5B. He's going to be using his right lateral cervical benders through eccentric work from 5B to 5A. Then at 5A, he could be using isometric of his right lateral cervical benders. And in 5B, that still picture, you know, he's got to be still for the picture. He could be using his right lateral cervical benders. So notice he's using his right lateral cervical benders the whole time because the external force is the same the whole time. 415 is going to be, well, who are those muscles? Who are the right lateral cervical benders? Right sternocleidomastoid, right erector spinae. Okay? Going the opposite way. External force trying to bring his right ear to right shoulder. He needs the muscles that are pulling left ear, left shoulder. He needs left lateral cervical benders. From A to B, 6A to 6B, it's going to be working. So he's going to be working through eccentric work from A to B, letting his neck go back to anatomical by still pulling with left lateral. Okay? So from A to B, eccentric work. From B to A, concentric work. Right? From B to A, making him go left ear, left shoulder through concentric work. So now it's, who are those muscles? Who are the left lateral cervical benders? Left sternocleidomastoid, left erector spinae. Now here is one that I just want to focus on the twist. So when he leans forward, that rope is trying to twist his head to the left transverse. And his transverse position actually stays the same. So he's not doing any kind of concentric or eccentric. He's doing an isometric contraction, but it's more forceful in 7B. Why? Because since he leaned forward, he put more tension on that band to want to spin his head to the left. So this is a case of two different isometric contractions with 7B having more work needed by the muscle group than 7A. But back to, who is it? Well, the external force is trying to twist his head to the left. The external force is trying to cause left transverse cervical rotation, so he needs to use his right transverse cervical rotators. Who are the right transverse cervical rotators? Left sternocleidomastoid, right erector spinae. Okay, I hope that was useful. Let me go to another picture. Which external oblique is being stretched here? Who's being lengthened? His trunk is twisted to the right. So therefore, his right transverse trunk rotators are being shortened, and his left transverse trunk rotators are being lengthened. Who's a left transverse trunk rotator? Right external. So his right external oblique would be lengthened in this picture. Okay, guys. Which external oblique? Okay, she goes, let's just start from the picture on the right. Okay, so that way we can at least establish who's working. Then we could say she brings it back up, she lets it down. Okay, which external oblique? Right external oblique. And that right external oblique is going to be working concentrically from there to there. And it's going to be working eccentrically from there to there. And that brings us back to our first practice question, okay? So I hope this practice helped you. Go back and do them all over again. You could even turn the sound off and just look at the different pictures. You can create different exercises yourself, stretching and working, okay? So I hope this was helpful. Obviously, hit me up if you guys have any questions. And I hope everybody's well. Bye-bye.